Pluto is a dwarf planet in the Kuiper Belt, a donut-shaped region of icy bodies beyond the orbit of Neptune. There may be millions of these icy objects, collectively referred to as Kuiper Belt objects or trans-Neptunian objects, in this distant region of our solar system. Pluto, which is smaller than Earth's moon, has a heart-shaped glacier that's the size of Texas and Oklahoma. This fascinating world has blue skies, spinning moons, mountains as high as the Rockies, and it snows, but the snow is red. Hello and welcome to KYC News. Please don't forget to subscribe and hit the bell icon. On July 14, 2015, NASA's New Horizons spacecraft made its historic flight through the Pluto system, providing the first close-up images of Pluto and its moons and collecting other data that has transformed our understanding of these mysterious worlds on the solar system's outer frontier. In the years since that groundbreaking flyby, nearly every conjecture about Pluto possibly being an inert ball of ice has been thrown out the window or flipped on its head. It's clear to me that the solar system saved the best for last, said Alan Stern, New Horizons principal investigator from the Southwest Research Institute, Boulder, Colorado. We could not have explored a more fascinating or scientifically important planet at the edge of our solar system. The New Horizons team worked for 15 years to plan and execute this flyby, and Pluto paid us back in spades. Pluto was once considered the 9th planet in the solar system. It was demoted in 2006. Pluto is the largest known dwarf planet in the solar system and used to be considered the 9th and most distant planet from the Sun. The strange world is located in the Kuiper Belt, a zone beyond the orbit of Neptune brimming with hundreds of thousands of rocky, icy bodies each larger than 62 miles, 100 kilometers, across, as well as 1 trillion or more comets. Pluto stopped being a planet in 2006 when it was reclassified as a dwarf planet, a demotion that attracted controversy and stirred debate in the scientific community and among the general public. American astronomer Percival Lowell first suggested that Pluto existed in 1905 when he observed strange deviations in the orbits of Neptune and Uranus. Lowell thought there must be another whose gravity is tugging on these ice giants, causing discrepancies in their orbits. Lowell proceeded to predict the mystery planet's location in 1915 but died 15 years before its discovery. Pluto was eventually discovered in 1930 by Clyde Tombaugh at the Lowell Observatory, based on predictions by Lowell and other astronomers. Pluto got its name from 11-year-old Venetia Burney of Oxford, England, who suggested to her grandfather that the New World get its name from the Roman god of the underworld. Her grandfather then passed the name on to Lowell Observatory. The name also honors Percival Lowell, whose initials are the first 2 letters of Pluto. Since Pluto is so far from Earth, little was known about the dwarf planet's size or surface conditions until 2015, when NASA's New Horizons space probe made a close flyby of Pluto. New Horizons showed that Pluto has a diameter of 1,473 miles, 2,370 kilometers, less than 1/5 the diameter of Earth, and only about 2/3 as wide as Earth's moon. Observations of Pluto's surface by the New Horizons spacecraft revealed a variety of surface features, including mountains that reach as high as 11,000 feet, 3,500 meters, comparable to the Rocky Mountains on Earth. While methane and nitrogen ice cover much of the surface of Pluto, these materials are not strong enough to support such enormous peaks, so scientists suspect that the mountains are formed on a bedrock of water ice. Pluto's surface is also covered in an abundance of methane ice, but New Horizons scientists have observed significant differences in the way the ice reflects light across the dwarf planet's surface. The dwarf planet also possesses ice-ridged terrain that appears to look like a snakeskin. Astronomers spotted similar features to Earth's penitents, or erosion-formed features on mountainous terrain. The Pluto features are much larger. They are estimated at 1,650 feet, 500 meters, tall, while the Earth features are only a few meters in size. Another distinct feature on Pluto's surface is a large heart-shaped region known unofficially as Tombaugh Regio, after Clyde Tombaugh, regio is Latin for region. The left side of the region, an area that takes on the shape of an ice cream cone, is covered in carbon monoxide ice. Other variations in the composition of surface materials have been identified within the heart of Pluto. In the center left of Tombow Regio is a very smooth region unofficially known by the New Horizons team as Sputnik Planum, after Earth's first artificial satellite, Sputnik. This region of Pluto's surface lacks craters caused by meteorite impacts, suggesting that the area is, on a geologic timescale, very young, no more than 100 million years old. It's possible that this region is still being shaped and changed by geologic processes. These icy plains also display dark streaks that are a few miles long and aligned in the same direction. It's possible the lines are created by harsh winds blowing across the dwarf planet's surface. NASA's Hubble Space Telescope has also revealed evidence that Pluto's crust could contain complex organic molecules. Pluto's surface is one of the coldest places in the solar system. Temperatures here can drop to around -375 to -400 degrees Fahrenheit, -226 to -240 degrees Celsius. When compared with past images, pictures of Pluto taken by the Hubble Space Telescope revealed that the dwarf planet had apparently grown redder over time, apparently due to seasonal changes. Pluto may have, or may have had, a subsurface ocean, although the evidence is still out on that finding. If the subsurface ocean existed, it could have greatly affected Pluto's history. For example, scientists found that the zone of Sputnik Planitia redirected Pluto's orientation due to the amount of ice in the area, which was so heavy it affected Pluto overall. New Horizons estimated the ice is roughly 6 miles, 10 kilometers thick. A subsurface ocean is the best explanation for the evidence, the researchers added, although looking at less likely scenarios, a thicker ice layer or movements in the rock may be responsible for the movement. If Pluto did have a liquid ocean and enough energy, some scientists think Pluto could harbor life. Some of Pluto's parameters, according to NASA, opens in new tab. Atmospheric composition, methane, nitrogen. Observations by New Horizons show that Pluto's atmosphere extends as far as 1,000 miles, 1,600 kilometers, above the surface of the dwarf planet. Magnetic field. It remains unknown whether Pluto has a magnetic field, but the dwarf planet's small size and slow rotation suggest it has little to no such field. Chemical composition. Pluto probably consists of a mixture of 70% rock and 30% water ice. Internal structure. The dwarf planet probably has a rocky core surrounded by a mantle of water ice, with more exotic ices such as methane, carbon monoxide, and nitrogen ice coating the surface. Pluto's highly elliptical orbit can take it more than 49 times as far out from the Sun as Earth. Since the dwarf planet's orbit is so eccentric, or far from circular, Pluto's distance from the Sun can vary considerably. The dwarf planet actually gets closer to the Sun than Neptune is for 20 years out of Pluto's 248 Earth-years-long orbit, providing astronomers a rare chance to study this small, cold, distant world. As a result of that orbit, after 20 years as the 8th planet, in order going out from the Sun, in 1999, Pluto crossed Neptune's orbit to become the farthest planet from the Sun, until it was demoted to the status of dwarf planet. When Pluto is closer to the Sun, its surface ices thaw and temporarily form a thin atmosphere, consisting mostly of nitrogen, with some methane. Pluto's low gravity, which is a little more than 1/20th that of Earth's, causes this atmosphere to extend much higher in altitude than Earth's. When traveling farther away from the Sun, most of Pluto's atmosphere is thought to freeze and all but disappear. Still, in the time that it does have an atmosphere, Pluto can apparently experience strong winds. The atmosphere also has brightness variations that could be explained by gravity waves or air flowing over mountains.